Good afternoon, everyone. My name is Sebastian Schormann, and I'm a third-year biomedical sciences major, but I work in the biology department with Dr. Rout trying to improve STEM education. Our title, Putting Active Learning into Motion, or Putting it into Osmotion, will make a little bit more sense in a couple of minutes, but until then, first I want to pose a question to the audience. Please raise your hand if you've ever been in a class where, no matter what you did, there was some concept that you just couldn't understand. You studied it, you reread the book, you watched the lectures, you watched the Khan Academy videos, and it just didn't make sense. So, what if the problem is not with the material, but it's with the way that it was taught? Here's a quote from here's a quote based off of an ancient Chinese proverb that goes, "What I hear, I forget. What I see, I remember. And what I do, I understand." So hearing and seeing, that's what's happening right now, right? I'm presenting this information to you, the audience, with the hopes that when you leave today, you will remember at least some of it. But is that really going to happen? That is part of the passive learning process. I want to note that there is a better way, and it's called active learning. So active meaning to be involved, and active learning meaning involving students in the process of learning. So having students do things so that they can understand it instead of just memorizing it. So we have reviews and meta-analyses that show that active learning is more beneficial than passive learning. But then why isn't it universally implemented into all these classrooms? To know that, we have to look at the classrooms, right? So here's UAB's current student-to-faculty ratio. It's about 18:1. This small class size is great for engaging students and putting them into a situation where active learning is directly implementable. But now imagine trying to do that same thing when you have a class size of 160:1. So just like those introductory science courses, imagine trying to implement active learning where it's just not so feasible because of the large class size. So instead, teachers turn to those passive learning processes. Osmosis and diffusion at UAB is one of those concepts that students just have a really hard time understanding. It's one of those difficult concepts and one of those large introductory courses that when you get presented information like this and you're expected to remember it, what are you going to do? Looking at these graphs, I mean, it's not very clear, but we're expecting students to look at these and understand them. So, instead of looking at osmosis and diffusion in that way, we decided to implement an active learning. So what if it didn't have to be like that? What if you didn't have to learn it looking at those graphs? That is what drove us to try and implement an active learning module where students are doing the stuff so that they can understand it. In this case, the osmotion kinetic activity, students are physically reenacting the process where they themselves are the water and solute molecules. By doing this, by physically moving around as well as constantly interacting with the people who are leading the sessions as well as with their peers, you'd expect these students to perform better, right? And that's exactly what the results show. So results were taken using an assessment based off of the ODCA, Osmosis and Diffusion Conceptual Assessment. The assessment was given prior to the active learning module and after the active learning module. And as you can see, the average score given after the active learning module was significantly higher than the one given before. Additionally, students found the osmotion learning activity, 62% of them found it beneficial. Although you do see a big red bar there, that means there is room for improvement. But I do want to note that even though the process wasn't perfect, it still worked for these students. Our goal was to change the way that osmosis and diffusion was traditionally taught. Instead of having students focus on learning the what, these students are focused on learning the why. And the results show that, indeed, by implementing active learning, they can improve their understanding of osmosis and diffusion. But it's more than just that. That can be applied to multiple topics across multiple courses, including all the things that you raised your hand for earlier today. I want to leave you with this. If you don't know what you don't know, then you're probably in trouble. But if you do know what it is that you don't know, then you just need to find the best way to learn it. Thank you.